Hello. Today we're going to look at nuclear fission, which is where a large nucleus splits up into smaller nuclei, and radioactivity, which is where atoms decay, either by the emission of alpha particles or beta particles or gamma rays. An atom consists of a nucleus and surrounding or orbiting electrons. The nucleus consists of protons and neutrons, and the number of protons in the nucleus determines the element. The periodic table lists the elements in the order of protons. But for all elements apart from hydrogen, the nucleus contains more than one proton. And protons are positively charged. And we know from the Coulomb force, or the electromagnetic electrostatic force, that like charges repel. So why doesn't the nucleus blast apart as these protons all try to get away from one another? The answer is that the strong nuclear force holds the nucleus together. But what we do notice is that atoms with about 100 protons in their nucleus tend to break up. And that suggests that the nuclear force which is holding the nucleus together is about 100 times stronger than the Coulomb force. As I said, the periodic table shows elements in order of the number of protons in the nucleus. But how many neutrons can each atom have? The chart shows the line of stability, that's the red line, and it's the number of neutrons that can exist with the given number of protons so that the element is stable. For example, iron has 26 protons, and it also has in its most stable form 30 neutrons, so that it has 56 protons and neutrons, which together we call nucleons. Elements with different numbers of neutrons but the same number of protons are called isotopes. You'll notice that the red line does not follow the n equals z line. In other words, elements are not most stable when they have the same number of protons as neutrons. As we go towards the higher end of the elements, the number of neutrons in a stable nucleus will exceed the number of protons. And for example, when you have 80 protons in a nucleus, you're likely to have about 110 neutrons in order for that nucleus to be stable. A nucleus is likely to be unstable if it has either too many neutrons, in other words, it's in this part of the chart, or if it has too few neutrons, which means it's in this part of the chart, or if it has too many nucleons, in other words, it's right up here somewhere, or if it has too much energy. There are three types of radioactive emissions: alpha, beta, and gamma. Alpha is just the nucleus of a helium atom. It consists of 2 protons and 2 neutrons. Beta is simply an electron. At the time that beta rays were named, people didn't realise that they were electrons. And gamma rays are part of the electromagnetic spectrum. They are just the same as light or X-rays, but they have even lower wavelengths and higher frequencies. Alpha particles tend to be emitted from the heavier atoms, those that have 82 or more protons in the nucleus. When an alpha particle is emitted from a nucleus, you can see that that nucleus will lose 2 protons and 2 neutrons. So if we take uranium, which has 92 protons and a total of 238 nucleons, which means that the number of neutrons is 238 minus 92, which is 146, then that will produce thorium, which has 90 protons and 234 nucleons altogether, plus an alpha particle. And if you notice, the uranium had 92 protons, thorium has only 90, because the other two are in the alpha particle. Uranium had 238 nucleons, that's protons and neutrons, whereas thorium has only 234. The difference is 4 because there are 4 nucleons in the alpha particle. Beta particles are emitted, which are electrons, if the nucleus has too many neutrons. And this is achieved by what's called the weak interaction. One of the neutrons is converted into a proton with the emission of a beta particle, or an electron. So, for example, rhenium, which has 75 protons and a total of 187 nucleons, will decay into osmium, which has 76 protons and 187 nucleons, plus a beta particle. Now you'll notice that the number of protons has actually increased, but the total number of nucleons has remained the same, because all that's happened is one neutron has become a proton. But to balance it, since a proton is positively charged and a neutron isn't, we have to have a negative charge coming out, and that's the negatively charged electron. You can also have the emission of what are called beta plus particles. These are simply anti-electrons or antimatter electrons. They are exactly the same as electrons, except they have a positive charge instead of a negative charge. And in those circumstances, instead of a neutron being converted to a proton is converted into a neutron. And beta plus emission takes place in nuclei with too few neutrons. Finally, gamma emission comes from nuclei which have too much energy. The gamma rays are high energy electromagnetic rays, and they carry energy away from a high energy nucleus. Whenever you have fission or radioactivity, some things will be conserved. Those things will be energy, momentum, charge, and the nucleon number. But mass is not conserved. And that's how we get energy, because mass is converted into energy by the formula E equals mc squared.